job of mRNA is to carry the genetic message from DNA to the ribosome. The three steps of translation are initiation, elongation, and termination. The job of mRNA is to carry the genetic message from DNA in the nucleus to the ribosome for the production of the specific protein each gene codes for. Once mRNA arrives at the ribosome, there is a chain of events that must take place. The ribosome is a highly complex cellular machine. It is largely made up of specialized RNA known as ribosomal RNA or rRNA, as well as dozens of distinct proteins. Ribosomes consist of two subunits. The larger of the two is the 60 subunit, and the smaller of the two is the 40 subunit. They fit together and work as one to translate mRNA. Initiation depends on specialized protein helpers called initiation factors. Their job is to help the ribosome subunits, tRNA and mRNA, find each other. Moving all of these initiation ingredients around requires energy. The energy needed is provided by guanosine triphosphate. Guanosine triphosphate, or GTP, is a common energy currency molecule that's similar to ATP. Eukaryotic initiation factor 2, or EIF2, mediates the binding of the initiator tRNA, which carries the initiator amino acid methionine to the ribosome. Eukaryotic initiation factor 4, or EIF4, recognizes and attaches to the 5' cap, or 7-methylguanosine cap, of the mRNA. This initiation factor helps direct the ribosomal 40 subunit complex to the cap of the mRNA like a homing beacon. Once the small subunit attaches to the 5' cap of the mRNA, it begins to scan the mRNA in the 5' to 3' direction, searching for the start codon AUG. When the start codon is found, the large ribosomal subunit joins the small, and all initiation factors, including the cap-binding protein, or CBP, are released. The assembled ribosome has three sites. The A site is the entry site for new charged tRNA. But what is charged tRNA? Every piece of tRNA that comes into the A site of the ribosome has an amino acid attached, which it deposits onto the growing polypeptide chain. Aminoacyl tRNA synthetase is an enzyme that attaches these amino acids to the corresponding tRNA. This activates an amino acid and charges the tRNA. This three-step chemical reaction begins when aminoacyl tRNA synthetase acts as the catalyst for the hydrolysis of ATP. In this step, ATP loses two phosphates and becomes linked to the amino acid as adenosine monophosphate. This is necessary because it provides energy to drive subsequent steps in the tRNA charging process. An amino acid also binds to the enzyme, losing its AMP molecule. Using the energy released from the loss of AMP, the aminoacyl tRNA synthetase attaches the amino acid to the tRNA molecule and then dissociates from it. The P site is where peptidyl tRNA is formed in the ribosome. Peptidyl tRNA carries the growing polypeptide chain. Peptidyl transferase is the primary enzymatic function of the ribosome, as it forms the peptide bonds between the amino acid as it adds them to the chain. The E site, or exit site, is where the tRNA exits the ribosome once it has delivered its amino acid. The next step in translation is elongation, and is the most rapid part of translation. Elongation factors are proteins that facilitate this process through the formation of new peptide bonds, resulting in the elongation of the amino acid chain. Here's how it works. A new tRNA charged with an amino acid enters the A site. The anticodon of the incoming tRNA is matched against the mRNA codon. This is a proofreading step. tRNA with the incorrect anticodons are kicked out and replaced by tRNA with the correct anticodon. The next step of elongation is a reaction called peptidyl transfer, catalyzed by peptidyl transferase. The polypeptide is removed from the tRNA in the P site and transferred to the amino acid at the A site. This transfer is accompanied by the formation of a peptide bond between the amino acid at the A site and the polypeptide, lengthening the polypeptide by one amino acid. At the same time, the ribosome migrates forward by one triplet, shifting the now empty tRNA from the P site to the E site and the tRNA from the A site to the P site. This cycle is repeated for each codon on the mRNA. Termination begins when any one of the 3 stop codons on the mRNA is in the A site. No tRNA will come into the A site once the stop codon is reached because no tRNA matches that sequence. However, there is a protein that does recognize this sequence called a release factor. Once the release factor protein bonds, it catalyzes a reaction that cleaves the bond between polypeptide and tRNA. The ribosome then disassociates into its 2 subunits and is ready for another round of mRNA.